Okay, I just want to take a minute to run through where we're going next and what we've done. If we were to look at we've selected the face. I'm just going through the kind of like the diagram of this code. We've selected the face. We've got the UV divisions. I have the panel triangle in this drawing hooked up, but we're actually not using it because it's dead-ended, so you could just ignore this for now. Well, you see those are feeding into our quad panel. We found the polygon by points, so we could find the center of the polygon. So we could use that to develop a surface normal, which was that little vector coming out. And we visualized it with the plane by the origin normal. And then we're putting all those planes in to create an idea of a coordinate system that allows us to identify that plane where it exists and transfer it to the other one. So where we're going to go with that is we're going to take all of those planes, make a coordinate system out of it, and then take the tool here is to take the original geometry, the coordinate system that matches with it, and put it into a new contextual geometry system, which is actually just a flat plane of XY space, no Z space. And then over here, all we're doing is we're exporting it out so we can visualize it in Revit. So the key here, though, is we're up almost to this point, I think, coordinate system by plane in our actual working one. And we're building to have the right components to do that transform. But what we really need is another grid, another reference plane to establish those points. So we take that, so up here now on the top, this whole stream through here is just to create an array. So we take the number of elements, and I multiply it by 2 because it's a UV shape, so we come up with 25. I then take it through a couple of reiterations. So I make a XY point by coordinate array, and I call each one of those points that comes out of it an origin point so that it has its own unique coordinate system. That's a list of lists. We'll see when we go through it. So I have to flatten it out, and then I have to do one more transform to it so that then that new coordinate system aligns with the one in sequence that we're working from the original objects. So let's go back. I'm going to drag this down now. We'll go back to our dynamo definition. And like I said, we're up to this plane by origin normal. And now we'll do one more thing here before we leave this. We're going to look for the coordinate system by plane because we're trying to develop two coordinate systems. Coordinate system. And let's see we want it to come in as a plane. There it is, I believe, plane, and we want it to come out as a coordinate system. So we'll hook those together. And now we have that little indicator of it being a coordinate system with the red and the blue as we're familiar to in green. Now let's go back and look at creating some sort of an array. So we have all of these panels now that are on the surface, and we want to transform them to the new surface. Like I said, I'll move that out of the way, and I'll move the 5 up here so we can actually use it again. And I'm going to create a code block. And actually, I learned a shortcut for that. The code block is to double click the left mouse button. And we're just going to do that x times 2. And it will plug the 5 into that, and it'll give us 10 elements. And we're actually, you'll see how this moves along. The idea is that we're going to make an array, so we want it to move in 2 different directions. So we take that, and I'll do it step by step. We'll make another code block, and I'll double click to get it created, and it'll be a sequence from 0 to x, and I don't know why that's not happy. Maybe because it doesn't have the x value. There we go. And now we have our 11 points that we want. And we're going to make another code block. And this is actually going to be like our spacer code block. Actually, what I'll do is I'm going to make this a little different than I'd actually set it up. I'll do it x times y. I'll call it space. We'll make a little slider for that. So we'll feed our x into this, and we'll make a slider, a number slider, and we're going to rename this spacing. I'll call it space so it matches the other one. And this will set to 1 to 100, so we'll just go in increments of 1, and I'll default this at 20. And we'll go ahead and we'll go to, I'll grab the watch box right away, and we'll take a look at what we're getting out of this. All right, so we're getting a list of 11 items that are spaced 20 feet apart. Remember, this is a pretty huge surface, so we're kind of stretching them out. And we're gonna use a points by coordinate to create a whole bunch of points that will be our origins for the panels to sit on. So you do point. And we'll feed these both in the x and the y. And we'll take a look at what that looks like when it comes out. So we have a list of 11 points, and here's what the problem is. We have only 11 points, but we really want to have the cross product of this. So I'm going to go to lacing and make a cross product, and that's going to create an array. And you're actually seeing, if you look up here in the corner, you're seeing that array now being created back here. So now we have a 121 points, and it's more than what we need for the panels, but once it's finished, those are just extra spaces. That's as far as we're going to go with the, we can make this adjustable by how we manipulate some of this math, and we could go back and look at that later on. Okay, so now we have this idea of we want to be able to create a coordinate system now over here that we can take these and transform them to. So we need a coordinate system by origin, it's called. Oops. And let's see if that's right. What we want to come out of it is an origin. We want to put a point in and have it come out as a coordinate system. So let's feed that in. And those then highlight as a coordinate system. So we're doing well so far. And let's take a look at what that data that comes out. All right, so that's a list that, like I said, is an ordered list. And what it would do is it would keep repeating elements. So we're going to go ahead and flatten that down. Because every time we get a panel, we want to use the next panel after that. So we want a nice long list to feed that into. So I've flattened that out. And now if you'll notice, I'll zoom in here a little bit. And we'll grab the watch box here. So we have a list. We have, let's zoom all the way down here. We have 10 lists with 10 items in it each, or 11. That's how we get 121. So if I feed this into it now, you'll notice that that list is flattened out. So each panel that we move will have one specific coordinate point to be attached to. Now, the next thing that's going to happen is our idea of taking this one coordinate system that we created for the panels and mapping it to the new coordinate system. And we're going to use the geometry transform. two coordinate systems. There we go. Transform from one coordinate system to another. And so our first coordinate system is the from coordinate system. And this one is the to coordinate system. And the geometry is actually the, let me just check to make sure, it is the polygon by points. And let's go and find that. So let's go over here and polygon by points and plug that in, and I believe it will error out or it won't function. I think we come up with, well, we've got a list of 25 items. But I found the problem was, I think they're all, if we zoom in around here, I think they're all piled up on the one. Yeah, here they are. They're all piled up on the one coordinate system. And that the reason for that is, let me just try to zoom up here so you can see how they're all piled up on top of each other. So now we've got all the panels pulled down into the flat surface, except for we're not spreading them out. And that has to do with the way the lists are functioning. So we have this idea that the list, and I'm actually not sure now when I think back about it, what I'd actually done to straighten this out, but let's go ahead. I did a list create, and I think it was let me just step through it and then I'll step backwards. I'll do the list create, and we'll make a duplicate watch box. I think if you hit the control down and pull over, if you hold control down and you click in with the left mouse button, you can drag over a new watch box. And I'm going to plug in the new coordinate system. And now what's happening is, and this is where I could have done this the other way around, but if we look at this coordinate system, I'm going to make another watch box. Oops. And I'll drag this coordinate system into it. You'll notice that I have a list in a list, so it's a nested list. So I'm trying to make this list and that list match each other. So what actually happened is, in the error of why these are all sitting on top of each other, is that this was looking for, it took the first list element and put all of the parts in it, and the original or the grid system that we'd created was just a pure list, especially since we'd flattened it out. If I went back and grabbed it here, it would be useless because it was lists of lists. So we flattened it, but we actually needed to back up and nest it into another list to make it match the other one. I probably also could have taken this coordinate system and flattened it to get rid of the list. But the hack here is just to make a list of lists, which solves the problem. And so if I just take, I'm going to just get the watch box out of there now. And plug that into the geometry. Oops, not the geometry, hold on. Plug it into the new coordinate system. There we go. All right, now we have our panels all laid out. And I can get rid of this. Let's go to a view where we can now circle back down. And now we have all of our panels laid out. We're not going to get into the idea of nesting these, because what I want to do next is I want to just switch over to a triangular form, because I want to go through that idea of getting a more planar surface. But you can see I made the array way too big. I could go back. What a fix for this is to go back and think about what I had originally done and generating this array geometry. I made 5 by 5. I don't know why I actually went to this other bit of code block here now that I'm thinking about it. Let's just strip that out for a minute. I needed an array of numbers, so that's what I'm doing there. But I've got too many. Let's see if I just make this, plug in the, there we go, that's much more rational. We don't actually need this element. So we have now a much smaller grid. So the idea here is we have 5, and we go from 0 to 5 in in X direction. If we slide this around, you'll notice how we can actually space out these elements. Maybe I'll zoom in here a little bit so you can see. So now we have control over making sure that one doesn't overlay the other as we were going to go through and make a drawing or whatever of these. Next thing we're going to do is, I'll end this clip now because we've been going through, this would be a good chance for you to, if you want to take a break. And then I'll come back and we'll make these into solids so we can import them back into Revit. Let's see, we'll go back and take a peek real quick at what's going on in Revit. So in Revit now we have all of our panels created out as geometry, but we can't actually reference these. If we were to go to the site plan view of this, we can't, these are just ghosted pieces of dynamo geometry that we can't actually make any kind of drawings or, so we need to add, we need to push through some Revit usable geometry, and we'll do that in the next clip. As soon as I can figure out how to shut the recorder off.